Hey guys, welcome to today's episode of Fun with Functions. Today we're going to be doing function transformations, and this really is going to be fun. If you have not gotten your student understanding log, please get that so you can write down the CLO. If you do not have your calculator, please get that. We're going to be using that, so pause if you haven't done those things and get that together, but quickly, because I'm going to have you turn in these notes by the end of the period. And you're back. Okay, so function transformations. Okay, so it's just kind of taking a parent function and moving it around. Write down what I have so far, and we're just going to kind of fill out a table. And the first thing we're going to put in our table under function change, let's play around with our parent function for the quadratic, which is just x squared. And this is our beginning, so over here we're going to put no change. Okay, nothing's happening right now. It's just our parent function, right? The parent function is just what it looks like without any other numbers or variables, just x squared. That's going to be our basic parabola. So if you go over to your calculator, go to the y equals, and go ahead and put in x squared. So there's x squared. I'm going to do a zoom 6, our basic window, which is domain from -10 to +10, and range from -10 to +10. So if I just hit zoom 6, that's what it'll give me. It'll give me a good parabola. Okay, there's our parent function, right? So the first thing that we're going to talk about is if we just add a constant, and a constant, I'm going to throw that under academic language. A constant is a number without a variable in an equation, okay? So we are just going to add a constant at the end. It can be any number you want. So what we have here is f of x equals x squared, and we want to add a constant on there. And you can pick your favorite number just to make sure that you're working with that number. I'm going to pick 3. Okay. So if I just add 3 at the end there, I'm adding it to the end of my function, what's going to happen? What is going to be my resulting movement? Let's check it out. Well, now I want to underline that. Okay, let's check it out. So we'll go back to y equals. Keep the x squared there. We're going to add x, another one, x squared. And then we're going to add your constant. It could be whatever constant you want. And we're going to graph it again and see what happens. Okay? And the resulting movement is that it shifted, okay? That is under our academic language. It shifted up 3. So if you add 3 at the end of your function, it shifts it up 3. I'm not going to write that down, so I'll be able to tell who's actually listening to this and who's just writing down what's there. But please take a moment and write down in your table here exactly what happened there. So x squared, when I added 3 to x squared, it shifted it up 3. Now, let's subtract a number, and you can already guess probably what's going to happen. But how about instead of adding 3, and I'm just going to pick a different number, we subtract 5. Okay, so my movement, my function change is I'm going to say, let's see, f of x squared minus 5. And then what's going to happen there? Oh, and I put plus 5, but I wanted to put minus 5, right? Minus 5. And the same graph should work. And what we're talking about is we're talking about the resulting movement from the original parent function. So I'm going to leave the original parent function there. There's the original parent function. And as you can see, and you probably already guessed, that it shifts down, a vertical shift down by 5. So if you add 3, At the end, it's going to move it up 3. If you subtract 5, it's going to shift it down 5. So please take a moment and write down what the resulting movement was. Pause it. I'm just going to keep going. So I think, like right now you're thinking, hey, I got it. Like you add, you go up, you subtract, you go down. And it's moving it around or along, up and down the y-axis, right? So now we're going to shift it left and right on the x-axis. But something funny is going to happen. So in order to shift it around the x, back and forth on the x-axis, here's how we're going to do it. And I'll use my 3. Again, it could be any number, any constant. And the way you move it around the x is you do this. So let's do x plus 3. And then you square it. Okay? So if you want to move it around the x, you have to put it in parentheses with the x, and then the exponent goes on the outside. All right? So x plus 3, all of that squared, what's going to happen? So ask yourself right now, is it going to move to the right or is it going to move to the left? All right? So let's go. I'm going to replace this second equation because, again, we still want that parent function. But we want parentheses, right? So parenthesis x plus 3 squared. Okay, graph it. There's our parent function. Oh, and it moved it towards the negative. So we put plus 3, but there's the tricky part. It actually moved it back 3, which is really weird, right? It moved it to the left. So please write down what happens here and maybe even highlight it or put a star there, because forever in your math career now, you're going to have to remember that if you add 3 to the x value or any constant, it's going to shift it left along that x-axis. Okay, so you probably already know what's going to happen, but let's play around with it anyway. And let's do x minus 5 squared. So I'm going to go back to my y equals, change it, minus 5, and it's going to move it to the right 5. There's our parent function. Right? Just shifted it right along that x-axis, positive by 5. So please jot down the resulting movement that happens right there. Okay? All right, well, what else could we do? So we know how to move a function up and down. We know how to move it side to side. Let's talk about reflecting it over the x-axis. Reflecting it the x-axis here, so reflecting it over the x-axis means we're going to turn it upside down, okay? So what does that look like? I'm going to throw reflecting over here. What that means is if I have my parent function, I want to have it open down. I want to turn it upside down, reflect it about the x-axis. So the x-axis there is acting as the mirror that we are having a reflection in, okay? So my original function is x squared, and that's going to give me all positive values, right? Because it's squared. Any negative number squared is going to be positive. Any positive number squared is going to be positive. So, but I don't want positive values. If I flip it upside down, all of those y values have to be negative. They're below the x-axis. So we need to make whatever I get, so the x squared goes in parentheses, whatever I get, my answer, I need to then afterwards multiply it by a negative, and that's going to turn it negative. So let's check to see if I'm right. Okay, so let's delete out this equation, and we do the negative sign first. Actually, I'm going to make sure this one is the one you have to press for the negative at the bottom of the calculator. And then, and I really hope you're actually graphing this too, because you need a lot of practice with these calculators. And then in the middle of the parentheses, x squared. Okay, so let's see what happens. There's our parent function. Boom. There's the reflection across the x-axis. Everything that had been positive became negative, kind of like I am some days when I don't have enough sleep. Everything positive becomes negative. I have been reflected across the x-axis. So, cool. What's the other thing? If we reflect it that we want to know, I want to remind you to pause and fill in what the resulting movement was here in your notes so that you always can keep that. What's the other thing? If I reflect it about the x-axis, maybe I want to reflect it about the y-axis, right? So how would I do that? What do you guys think is going to happen with that? Let me pause it for a second and have you think. Nice. I hope your answer was move the negative sign inside the parentheses. So actually, you're still going to get positive values. You're not going to see any change in this one, except in the table. You'll see changes in the table. Oh, actually, you won't see changes in the table. There will be changes in the table, but it'll look exactly the same. F of x equals negative x squared. So we put a negative x squared in there. So let's see what it looks like. And what that means is every x value is going to be the exact opposite x value. Okay. And delete this out. Okay. And now as you can see, I re-entered in parenthesis, then negative x parenthesis, then squared. And if we graph that, we have our parent function and that function. And you don't see another function. Well, maybe you do because your calculators have color, but it's just the same exact function. But everything here was now here. It's just that in this particular case with this particular function, it doesn't look any different. But what you're going to write down is it's reflected across the y-axis, and that's what we did right there. So make sure you put that in the resulting movement. It's reflected across the y-axis. Okay. And the next thing we want to do is stretch it vertically. So what does that mean? We want to stretch it. We want to make it taller and skinnier. So the way we're going to do that is multiply my parent function by a number greater than 0. So let's make this 5. Okay? And let's see what happens. So we want to, let me just delete all of this here. I want you to do this with me. So 5 parenthesis x squared. Okay, we want the whole function multiplied by 5. And let's graph. So there's our parent function, and there you go. See it? We stretched it. We made it taller, and as it got taller, it got skinnier because every x value is now, or I'm sorry, every y value is now bigger by 5. Okay, and we can look at the table and see what that looks like. So here, my original y value was 1, and now it became 5. 5 times 1, right? We multiplied it by 5. Here, my original y value was 4, but I multiplied it by 5, and now my new one is 20, and so that's why it's reaching higher up each time. So under resulting movement, you want to put here that multiplying the entire function by 5 stretched it vertically, okay, which means up and down the y-axis, by 5, right? Stretched it vertically. Every y value is now 5 times more. Now, we can also make it shorter and fatter. And the way we do that is we multiply it by a number less than 1, but greater than 0. So let's make that 1/5. So let's make that 1/5 instead of 5. What happens? It should make it shorter and fatter. So instead of 5, I'm going to do 1/5, which I'm actually just going to do point, and then second insert 2, and let's see what happens. Okay? Yay! Fatter. We made it fatter. So in this case, we compressed this parent function by 5. So stretching, reach your arms up and make it taller. I'm stretching in my chair right now. And compressing, bring your arms down and to the side. So let's do this in class. Actually, right now I want to see you put your arms up. You're stretching, and bring your arms down. You're compressing, And so that's vertical stretching, vertical compressing. We can also do horizontal stretching and horizontal compressing by moving those numbers to the inside of the function, which actually, so like if we put 5 here times x, and then that whole thing squared, okay, and as per usual, it's probably going to do something different when we move that number to the inside. So let's try this. So in this case, we want parenthesis 5x parenthesis that squared. Okay. Cool. And what do you notice? It actually made it taller and skinnier, but what we're talking about is that the x value is bigger each time. Okay, so it did the opposite. When we multiplied it by a bigger number, it made it skinnier. So to make it fatter, if we do it on the inside to make it fatter, we should probably just move that 1/5 to the inside. So let's see if that works. Parenthesis 1/5 x parenthesis squared. Okay, what is going to happen? And you already know, even though the number is smaller, it's going to make it fatter. So 0.2 x parenthesis squared. Yep, way shorter and fatter. So it's a good thing to remember that when things are on the inside of the function with the x, it's probably going to do the opposite of what you think it's going to do. If it's outside the function and you're talking about the y, it's pretty straightforward. So I hope you wrote all of these things down. And should we do one large practice one right now? Because we can combine some of these. So let's make one. Let's take x squared, okay? And here's what I want you to do. Take x squared. I want you to create a function from x squared that flips it over, moves it, shifts up at 6 and to the left 4. Okay? Up 6 and to the left 4. Once you have that function done, I want you to write it down here and have me come over and check it for you. After I've checked it, I want you to take a picture of your notes and upload them as the assignment for the notes function transformations. Thanks for listening.